and go ahead. If you have any concerns about being on camera, of course, feel free to keep your cameras off for this webinar and your mics off. And there shouldn't be any issues, and we can also assist you with that if you have any trouble. Okay. Great, so I'll go ahead and get started here with some introductions. I know we're still admitting folks. I think we had almost 90 registrations for today's webinar, and it is a topic that was requested in a way, and you'll hear about that in just a little bit. This is our 9th Lake Stewardship Community of Practice webinar or in-person meeting. We've had a few different varieties of this session, and if you don't know me, my name's Brad. I'm the Executive Director here at the Alberta Lake Management Society. I'm headed into my 15th year with the organization, and despite all of the community-based monitoring work that we do, the reporting, the research, I have to say, I think engaging with our stewards is one of the most important things we work on. And that's because our stewards across Alberta are the ones who really put all of this work into practice and convert our monitoring efforts into management efforts. So I'm happy to continue providing this forum to support that, and really grateful to the Land Stewardship Centre of Canada, who's been a supporter of this webinar series and enabling us to provide our speakers with honorariums that are really critical to recognizing their effort and their time in pulling these off. We are joining you today, or I'm joining you today from Treaty 6 territory. This is also the North Saskatchewan region of the Otipemisiwak Métis government. And specifically today, as we discuss issues around lake recreation, I think it's important just to ground ourselves in how privileged we are to be able to talk about this issue on so many lakes that are ancestral territories for hunting, for gathering, for medicine, and for spirituality. So feeling very privileged every day to work on lakes and the natural environment and to talk about things like recreation. If you don't know our organization, I'm sure most of you do because you got an invite to this webinar, but we do work on this broad mission of healthy lakes for Alberta's future. And I have to acknowledge my great team. I have a few of them on the call today, helping out in the background. If you've engaged with the team at the Alberta Lake Management Society, I think I'm really lucky to work with some of the best folks. And I hope you feel the same way if you've had a chance to engage with any one of our team members. And I have to give a shout out as well to Kelsey Norton, who's on the call from the North Saskatchewan Watershed Association. Kelsey is a critical piece of the Lake Stewardship Community of Practice and does a lot of lake work over at the NSWA. And if we have time for breakout rooms today, excuse me, Kelsey will be helping to facilitate that. I see she's waving in the background there, so thanks, Kelsey. So where does this series really focused on recreation come from? Well, at our 2024 conference out in Hinton, I partnered with Dr. David Barrett from the University of Calgary to survey conference attendees about what are your #1 research questions, who should answer those questions, how much effort would it take to answer those questions. And the goal was to create a database of research questions that are really relevant to Alberta lakes and could be shared with graduate students or researchers across the country who are looking to do interesting lake research. And something that I didn't expect was that the majority or a large percentage of those questions were related to lake recreation. I thought for sure the #1 topic was going to be blue-green algae, cyanobacteria, and their toxins. No, water quantity and lake recreation were the #1 topics people had questions about. And so that's why we've kind of embarked on this 3-part series on lake recreation, which started with our previous webinar. Today is our second one, and then on Monday we have a third one on the topic of recreational carrying capacity on lakes. So I'll just give you a sense here of what were people asking when we surveyed them about lake research questions. They want to know, what is the impact of boat traffic on lake health? How are wake boats affecting shoreline and lake habitat in Alberta? What are the impacts of boats on disturbing lake bottoms and promoting algal blooms? So it was surprising to me that this is the number one thing that our attendees were thinking about, because if I was to plan a webinar series for the Lake Stewardship Community of Practice, it probably wouldn't have been on recreation. Again, it would have been on blue-green algae related topics or something like this, which are prevalent here in the province. So that was really helpful in guiding some of our work with the Lake Stewardship Community of Practice. And you can see here on our website, we do list all of our previous presentations, but most recently in February, we heard from Diana Paquette from Safe Quiet Lakes on topics related to wake and noise pollution and carrying capacity. So feel free to check out any of those previous webinars. And as I said, on Monday, we'll be continuing with this theme with the Lake Windermere Ambassadors Association on the issue of recreational carrying capacity. So they just recently developed a report on recreational carrying capacity for their small, shallow, narrow lake out in BC. And I think the results are quite interesting, especially related to conflict between, say, boaters and paddlers. So the QR code on your screen right now is a way to register for that event if you're not already registered. So today is a very similar structure to our previous webinars. The structure is very loose. If the presentation is going long, that's great. We'll just keep it going. But if we have time for breakout rooms following the presentation, we'll do that. And we've got some facilitators who can help lead us through some discussions related to today's presentation. With that, I'm really pleased to introduce our speaker for today. Dr. Chris Hauser is the Dean of Science at the University of Waterloo. He's a coastal geomorphologist by training and studies the impact of wave energy on shorelines. Recent investigations have allowed him to study wave energy on shorelines in Northern Ontario. And he also manages a coastal research group called COASTI, which uses citizen science data, which is, again, really relevant to the work that we're doing out here with all of our citizen science efforts. At our last webinar in the breakout rooms, we heard people questioning whether it was possible that boats could have a greater impact on shorelines than wind. And I think if anyone can help us navigate that question is Dr. Hauser. So without further ado, thank you for being with us today, and I'll invite you to share your screen and start your presentation.
Perfect. Thank you very much for that introduction, and thank you very much for having me today. And in fact, the focus of today's presentation is on that relative energy of vessel-generated waves relative to those that are generated by the wind, as well as some of the social science work that we've been doing, looking at the perceived impacts that they might have. Now, just as a background introduction, I'm at the University of Waterloo, and I've spent most of my career in the academic section and working in coastal barriers and looking at how they respond to sea level rise, storm activity, things like Hurricane Fiona hitting the north shore of PEI. But while I've tend to work in that environment from very early on, what got me excited about waves and wanting to go into this field was boat wakes. And in fact, I started working in 2007 on boat wakes, looking at whether or not post-Panamax ships were having an impact on the Savannah River. Now, in general, and if you look at the literature and you look at media reports, boat wakes are identified as being the reason for damage to infrastructure, safety to other boaters and swimmers, causing shoreline erosion, sediment resuspension and turbidity, which ultimately lead to algal blooms, as well as they do pose a nuisance and a disturbance. And this particular video taken from Lake Conway in Florida gives you an example. You can see the rocking of the docks and the boats. You can also see that they have a break wall that is being put in. This is a karst lake. It is just off of from Disney World. It's a lake that doesn't typically have large wind waves, And so the shoreline would never have been adapted to or in equilibrium with larger waves. These this wake boat that had just gone by, that wave is coming in here and does have that impact to the shoreline. I'll note that this lake is kind of special. It's the home to the Australian wakeboarding team during the Australian winter. So even though it is a relatively small lake, it gets significant amount of boating activity, and I was able to work with the homeowners associations there to better quantify that. And really, this is what you see. This is on that exact same lake. It's Lake Conway again in Florida, and you can see this wake boat coming through. And wake boats are ones that are designed in order to have to produce those large waves in their wake. And that ultimately is believed to be causing a lot of erosion, particularly in the cottage country area north of Toronto. Now, I'm not going to get, before I get into that, I just want to quickly go through what determines the size of a boat wake and the structure. And it can be broken down as to the speed of the vessel, how fast it's going relative to the wave that it's generating, the length of the vessel, and how that wave is basically being shed off the side of the boat, how people are driving it, whether it's in displacement where it's flat and slow, whether they're plowing through the water or ultimately at speed and planing. To give you an idea, this boat that I'm looking at right here, that I'm taking the video from the behind, is in displacement mode. It also, though, depends upon the distance from the sailing line. So the sailing line is exactly the middle spot where that boat is going down the small narrows. And as those waves propagate away from the boat, they do something called dispersion, where the longer waves travel faster than the shorter waves. And as a result, the waves are largest right at the sailing line and get smaller as they move towards the shoreline. Now, at the shoreline, they may increase a little bit in height through a process called shoaling, but in general, they're always going to be largest right at that sailing line. So the closer you are to that, the larger the waves will be. And ultimately, then it also depends on the type of activity. Are you just cruising around the lake like this, making relatively small wakes? Or are you plowing through that water? Are you purposely making a wake that is for wakeboarding or for water skiing? Or are you on a jet ski and just constantly going around and around in a circle? All those make that definition. Now, this gives you a better understanding of plowing versus planning. So this right now, he's in displacement mode, just really just sitting on top of the water, and he's going to finally get it into gear here. He's in displacement mode right now. Now he's about to start plowing, and that's where the waves get to be the very largest. And eventually, as he gets up to speed, he now moves into full planing mode. I will note when I took this video of my son, he didn't have a life jacket on. There are life jackets in that boat just for full notice. So one of the reasons also for showing this is that we boat. So in fact, this is our cottage lake in Northern Ontario, about 3 hours north of Toronto. And we boat every summer. We love to water ski, and my son loves to wakeboard. So these are things that it's not just something that we are doing and looking at independent of it. We're active users as well. Now, the big piece here is you can't really control for how the people are using their boat, their speeds, etc., the type of boat. One of the biggest controls that ultimately determines what's at that shoreline is how far away you are from the sailing line. So imagine this blue box is a lake, and the wind is coming from the left-hand side to the right, so the waves that it's generating are being started as ripples on the left-hand side and are eventually becoming full-size waves on the right-hand side. Those waves that are being created are those black lines that are coming up from the bottom, and they're increasing over what's called the fetch length. The fetch length is the distance over which the wind is blowing. The longer the fetch length, in general, the larger the waves that will be generated. And then as you increase the speed of that wind, the waves are even larger. So that top black line is the fastest wind speed. The bottom black line is the slowest wind speed. So anybody on the right-hand side of this lake is going to get very large wave heights. Now imagine that there were three different boats sailing along the middle here. The green boat is more on the left-hand side of the lake, so by the time its wake gets all the way over to the right-hand side, it's dispersed. It is much smaller. and it's largely smaller than wind speeds 2 and 3. A boat that is going down the middle of the lake has less of a distance to go, so that wake continues on and is a little bit larger. And somebody who is sailing or boating just closer to the right-hand shoreline, their wake doesn't have a lot of time for dispersion, and as a result, their wake heights are larger. So this behavior, in addition to how you are driving the boat, whether you're going around in circles, this is what's really going to define how much wake energy you have relative to that of the wind waves. And so this is where we started. So while I had worked on post-Panamax ships, the largest ships that moved through the Panama Canal, we during the pandemic, when we weren't allowed to do anything, I was sitting on the dock at Whitestone Lake in near Perry Sound and started thinking, well, let me go back to basics as to what I started in. And I was asking the question, do boat wakes, including those of our own, do they have an impact on the shoreline? Are they greater than that of the wind waves? And so here on Whitestone Lakes, you have a summer winds that tend to be light and they're very diurnal. They're strongest in the mid-afternoon, except during those times when you get a frontal storm that comes through. And this is when you've got a very strong north to northwest wind, large waves would be generated. And in fact, our cottage is in the direction in which I'm traveling in this boat in this picture, and the wind waves are generated from behind. So this is what a wake would actually look like. So what we use are something called a pressure transducer. It's just a simple little tube, and that tube has a diaphragm in it. And as the water level increases or decreases over it, it bends the diaphragm. And the bending of that diaphragm creates an electrical change in voltage, and we can then measure a wave moving across the water surface. Normally, these are about $10,000 a piece. We make them in our lab for about $100 to $150 each. So we were able to distribute quite a few. But this is what it would look like. So this on the x-axis, those are seconds. So this is a 1,000 second recording. And on the y-axis is water depth relative to mean water level. So mean water level, so just before this boat comes through, the water is relatively flat, and all of a sudden the wake comes through, and you can see that main part of the wake coming in where these waves are going up and down. And this is about a 3 to 4 centimeter wave. And then after the reflected wave, the wave that comes back and reflects off the shoreline. This is a more rocky environment, so it reflects quite a bit. And even hundreds of seconds later, you can still have a residual wave on that shoreline. So I'm going to refer to wakes and reflected wakes and waves, and I'm not going to talk about the residuals. We're not going to care about them. They're so small. They're not going to create much energy and do much in terms of total wave energy and activity at the shoreline. It's the main wake that's important. So in 2020, again, just measuring at the dock, what we did is we then got this data. I'll show you how it works a little bit later. We were able to then measure both the non-wakes, so things that are generated by the wind, and the wake energy and separate those two out. And you can see in the top part, after the ice had cleared, you get your frontal winds coming in, and you got these large fronts, and there was 5 main fronts that came through during that summer season. And then over that same period, you can see the wake energy. It tends to be very much based on the weekend pattern. And you can see that, for example, Canada Day civic holiday, August civic holiday, and Labor Day were the actual main peaks in wave energy. And if you follow that through from May through September, wind waves were strongest in May because not many people had got up to the cottage yet and put their docks in. But by the time you move into summer, particularly after Canada Day, the amount of total wave energy increased greater than the frontal storms, which means these lakes are experiencing waves that they don't typically or wouldn't typically experience during the summer months. If we just take the boat wakes, that first little bit, the main wakes in this particular case on this lake in 2020 represented 60% of the total wave energy. But when you then start to include the reflected wave, the wave that is the wave bouncing back off the shoreline, which still has an impact on those shallow environments and vegetation, etc., they actually account for 80% of all the wave energy on this lake. You can see a typical picture here. There's a small wind coming in from behind this image. So it's coming in directly from the southwest. That boat is coming in the opposite direction. It's creating a wake. But if you actually count all the different wakes on this lake, both directly formed as well as reflected, there are 8 different wake trains that are present here. And so once you start to include all those direct and indirectly reflected waves, wakes represent 80% of the total wave energy. So this led us to a further question. This is the first time that anybody had actually done this for recreational boats. I had previously done it for the post-Panamax ships. And so we started looking at other lakes within the region. And this particular one, this is Lake Joseph in Cottage Country. And we wanted to better understand what was the relative importance of those recreational boat wakes as it varies with lake configuration and shoreline type, and what are the perceived impacts associated with boating and boat wakes. And so in this case, we kept Whitestone Lake as our control lake, and we also went to Lake Rosso, Coshigawiggamog, Lake Roslyn, Whitestone, and Otter Lake. That's where we put in sensors, and we put in well over 30 sensors across these different lakes at different locations. And when we put them in, we didn't tell we worked directly with the property owner, but we didn't announce where those particular sites were so that they weren't tampered with or people didn't change their behavior in front of them. And so you can see those blue dots that those represent the lakes that we actually did the measurements in. So this again is some example wave data. This is almost 4,000 seconds of data, both in the top and in the middle image. And these come directly from Lake Joseph and from Lake Rosso. The yellow dot is the one from Lake Joseph. You can see, again, these wakes coming in, these big spikes of activity. These are boat wakes that are moving through over the course of 4,000 seconds. But you can also see that there's a lot of other wave activity happening. Whereas in the bottom one, the red one on Lake Rosso, the wave activity is relatively small, but the boat wakes are much larger. So we use a process called wavelet analysis. Wavelet analysis takes all that wave data, up and down motion, and basically pulls it apart into its different parts. And we can then separate what a wind wave looks like versus that of a wake. And wakes are very clearly identified by these that look like upside down or backwards commas. Once we can see those, we then are able to automatically extract that data. We define that as a boat wake and everything else as a wind wave. So in the Lake Joseph case here, wakes occurred 60% of the time, but because there was wind waves occurring, it was only 38% of the energy over that 4,000 seconds. Where in the second case, wakes were only 24% of the time, but they accounted for 58% of the energy in that 4,000 seconds. And this again from June 11th, 2022. Here's another way of looking at it. This is Lake Rosalind, a small lake in southern Ontario. You can again see some of the data that's up top. There's about 1,200 seconds of data. The wakes were about 6 centimeters on average, and the wind waves were just about 1 centimeter. We can then, using that wavelet analysis, extract out what is a wind wave versus what is an actual wake. And once we have that, we not only have the time, we have the energy associated with it. So what we found on Lake Rosalind over the course of the summer of 2022 is that wind waves were there 85% of the time, but boat wakes were there 15% of the time only. But boat wakes represented 94% of the total wave energy reaching the shoreline. Boat wakes also had wave periods, the time between waves, of 3 to 5 seconds, whereas wind waves were 1 to 2 seconds. So when you actually then can calculate what would be the speed of that orbital motion at the bottom, wind waves were about 2 centimeters per second, where boat wakes were 5 to 6 centimeters per second. Those 3 to 5 second waves are able to penetrate to the bottom, it's a shallow lake, and resuspend sediment. And they can actually have maximum velocities of 10 centimeters per second underneath some of the wake boats. whereas the wind waves had negligible orbital velocities and never came close to a speed that could actually entrain or resuspend material. So in Lake Roslin, as an example, it is an issue. 94% of all the wave energy on this small, shallow lake is associated with boat wakes. It's about a 500 meters around in terms of diameter, and there's a very strong diurnal cycle of wake or wave activity. Through the night, nothing's really happening, and during the day, you really pick up. And you can see it, and it's both jet skis, wake boats, and even just pontoon boats moving around. There is nowhere else to go within this lake. It's 500 meters across in terms of its main diameter. And then if you go vertically, you're looking at about 1 to 1.5 kilometers. There's not a lot of spot to go. So as a result, when you are boating on that lake, you're just constantly going around and around. And as a result, you have that algal bloom that is starting to develop because you're resuspending sediment. And in this small little picture, you can see a boat coming across the lake. That used to be a small marsh in the middle. That marsh is no longer present. Now here's a better picture of it. So what we know on Lake Roslin, again, a small, shallow lake with material that can be easily resuspended on the bottom. It was responsible for shoreline erosion, water mixing, sediment resuspension, which ultimately led to algal blooms, and the direct force of the wave of the boats going through the waves did lead to a direct force on the vegetation. But that's Lake Roslin. That's a very unique lake. So now let's go back to those other ones that are more in northern cottage country, which is on the Canadian Shield. Now, this is all the data put together. So in that top graph, fetch length is again the distance over which the wind can blow and make waves. The longer the fetch length, the bigger the wave that can be generated. So we went everything from a 500 meter, less than 500 meter, just a couple of hundred meters wide in terms of a small little narrows, all the way up to a fetch length of 2.5 kilometers on Lake Joseph. And so what we found is that the amount of wake energy was upwards of 90% in the areas of the smallest lakes and was down to only 70% in the largest lakes. And that was quite shocking that in fact, what we found is that this large lake, 2.5 kilometers, Lake Joseph, even though it has this large fetch, large waves that could be generated, you were still getting 70% of total wave energy was associated with wakes. And when you look at the deviation above and below that line, you can then break it down. We can then break it down based upon what type of environment was it. So was it an open, wide open area like Lake Joseph? Or was it in a narrows where people have to go through a very narrow section between two sections of a lake? Was it an arm, which is the outstretched part or long elongated bay? Or was it truly a bay or a closed environment? And that goes to the type of activity. So what we found is that bays and closed lakes, a closed lake would be like Lake Roslin, just perfectly closed, or a bay where you're in a truly cup-shaped bay, that there you had a higher than expected amount of wake energy. And the reason it goes to the behavior of how we work. In a closed lake, all you can do is go around in a circle, and in a bay, you go around in a circle, or you plow in or plow out. So as a result, in bays and closed environments, you get bigger wakes. In arms, you also tend to get larger wakes because it's wide enough that you can go at moderate to fast speeds, but once you go down it, you got to come back it. And so you just keep going up and down. Whereas narrows tend to be smaller, no wake zones, and people are abiding by them. And so while they are still high percentages, you get typically less than expected. And open is less than expected because simply the wakes have had time to disperse. I see there's questions coming in, but it's hard on this Zoom to be able to answer those questions in real time because I can't read them simultaneously.
No worries. We can throw them to you once you're done your presentation.
Perfect. Thank you very much.
Yeah.
Now, if I take that wave energy, and so this is basically the distribution of wave and wind waves in terms of their energy, and I've just done it as a cumulative percent. And what I find is that on small little lakes like Otter Lake, which had a fetch length of only 190 meters, is that here there is a statistically significant difference in the distribution of wave energy between wakes and wind waves. And that the boat wakes in this case were actually creating bigger, larger waves. It wasn't just that there were more waves, it was far greater than the wind waves were able to, the wind was able to generate. Whereas in another environment, Kashigawigamog, where the fetch in one spot was 2.1 kilometers, here you had more waves, but also those waves, because they had more time to disperse, weren't as large. They were closer to that of the wind waves. So there's two things here. One, once you put on boats, you automatically get more waves. In a smaller environment, not only do you get just more waves, you get typically more waves than the wind is able to generate, and those waves tend to be much larger. Whereas in a big lake, not only do you get more waves, it's just a little bit more, but they tend to be around the same size of the wind waves. So it's just twice as much energy, to put it bluntly. When you then look at the behavior, small little lakes, you get this interesting distribution, whether it's height or energy, is that the wakes account for about 80% of the total energy. But it's not just that there's that much more, it's that it's associated with extremely large waves that are capable of doing shoreline erosion, capable of resuspending sediment. Whereas on the large lakes, you really get a distribution that's very similar to that of the wind waves. So here your issue is not the size of the waves, it's just that you've added more waves, more of those wind waves. So it's twice as energetic as it would otherwise be. And when we break it down by the different lakes, actually, this is less important for this group because it's in Alberta. I'll just skip that. When you do it by fetch length and you look at the time, how much time were wakes present? In the smallest lakes, you typically find that wakes were only present about 8% of the time. But when you get up towards places like Joseph, you get wakes that are there for about 12% of the time. And the reason being is in a small lake, there's not much you can do. You just go around and around, and then you're done. In a big lake, you have simply more boats. You have more activity that can happen more continuously. So you have more time of that energy. So while the energy is less, it's just more consistent through time. Whereas in small lakes, there's not a lot of time in which it's happening, but it tends to be far more energetic. And again, you get more of that type of activity in bays and closed environments because you're just simply looping around. One of the big ones here is also jet skis. And I know, again, I can fully admit that jet ski is amazingly fun, and I have fun doing this as well. And what you do with the jet ski is you don't just cruise around necessarily, you're all over the place and you're constantly looping around. But I want you to look at this video. Look at how many wakes are being generated by just those two jet skis alone. That little boat that went down, which was actually um, my kids doing tubing, and I forgot to actually pay attention to them with the video, and I just started watching the jet skiers instead. Now you may be asking, well, does that do any damage? Is that really important? The fact is that this represents far more wave energy than this lake would ever get under normal situations. So therefore, it's not necessarily that it's bad or good, it's just far greater amount of energy, which is capable of moving sediment, capable of doing damage to vegetation, etc. So what we found through this, and I've done a very quick overview of a number of studies here, is that what we found in the cottage country of Ontario, boat wakes represent a significant source of wave energy in these fetch limited environments. The percent wave energy, the time, and in fact the number of wakes is directly related to the fetch length, but it varies with the shoreline type, whether it's a bay, a narrows, an open, an arms, because that is the type of behavior that determines the type of behavior. Individual wake energy, the energy in an individual wake is far greater in short-fetched environments and represents just an additional source of energy in long-fetched environments. So again, in short environments, not only are you doubling, tripling the amount of wave activity, they're just far bigger waves. We're in big fetch environments. They're not that much bigger in terms of size, but you've now doubled and tripled that energy. So there's a question that comes out of this, and it goes to two of the things that I saw in the survey that you guys had done previously, is a question of what kind of buffers, what kind of carrying capacity should we have to limit that impact? I will come back to that. I'm just going to make that as a teaser and come back to that towards the very end as kind of a wrap up. To add to this, we did a survey in perceptions. We asked people from across cottage country, we said, are wakes a problem? Tell us about it. And we had 635 people responded to our survey. And what we found from large, big number to small, little number, is that in smaller lakes, those with smaller fetch length, that the impact of boat wakes, traffic, level of safety, shoreline modification were higher. But as you got to larger lakes with larger fetch lengths, here it was boat traffic that became dominant. But overall, all the other ones weren't as important. So on the larger lakes, where you're just adding more energy, there wasn't as much evidence, and I'll come back and show you a little bit more, for shoreline erosion. What it was just how many boats were there. Whereas when you get to the smaller ones, that's where the erosion started to play. Now, I apologize, this graph is flipped. So now most impactful is 0, least impactful is 5. And when you then ask them, what is the biggest impact? On the smaller lakes, it was shoreline erosion. On the larger lakes, it was less impact that people were observing. Shoreline erosion was still the most impactful in those environments. But when you compare large fetch to small fetch environments, they're quite different. So shoreline erosion seems to be in this narrower length of fetch than it is overall. But when we asked people, again, we asked them, we said, what are the issues? 66% of all respondents focused on the type of boat, their operation, and their lack of experience. Personal watercraft, driving recklessly, doing donuts. Too many boats, unable to canoe. Excess speed in the river. Vessels are often used for water play. Why are there so many of us being held hostage to the abuse of the majority? Large, unmuffled, oversized engines. And some wakes do their surfing in the evening when the bay is calm. I'm going to come back to that last one because this did represent one of the issues that we did observe. If you take those same data and you start to drill down to things like shoreline erosion, safety, and damage, we found that only 9% of people actually gave us a direct example of shoreline erosion or talked about safety or damage. So as the wakes get bigger, the swells causes damage to in its path. It's overturning the lake bed. I'm deeper water, but I have to change my water filters now more than ever. That is sediment resuspension. Our water used to be clear. There used to be tons of wildlife. Swimmers were being rocked by waves created by passing boats. I've had to do $500 in dock repairs. I've had to do $30,000 in protecting a point on our property. I've had to install boat lifts. So when you actually look at who was able to give direct examples, it was very, very few. Most people focused on the activity. There was also biophysical impacts that people would identify. Here's just a few more of these examples. Shoreline eroded about 6 feet in the last 10 years. We have boats that are stirring up the lakes that are less than 20 meters wide and 8 feet deep. They're going too fast in shallows and chopping up weeds, stirring up sediment, etc. But again, this is just a small percentage of everybody who responded. It does work. When you then look at who was responding, it was places like Lake Roslyn. They did have a problem. They did have examples of shoreline erosion. They did have examples of sediment resuspension and algal blooms. But it wasn't everywhere. Now, again, as I mentioned, some of our sites were on the Canadian Shield. So obviously it's a rocky shoreline. So boat wakes should still be having a damage to infrastructure. If it's still has sandy or muddy bottoms. It should be sediment resuspension and eutrophication or algal bloom, temperature and mixing. We didn't see those examples. So in fact, few lakes, they might not have had an erodible shoreline, but there were still ways in which that wake could have had an effect on that shoreline. And part of it may have been that the damage has already been done. So if I use an example, this one here called in C is actually on a small narrows. It used to be, and it's a narrows on a dammed lake, which means that it had a natural, muddy, unconsolidated shoreline. Decades of boat wakes have now finally eroded it back to the bedrock. So many of these natural lakes, the wind waves have eroded it back to a rocky shoreline. Boat wakes are not going to have much of an impact, except for sediment resuspension, etc. On these smaller environments, particularly in dammed environments, boat wakes were going to have an impact, and they are going to erode back until they reach some type of hardened structure. So what we found in the survey, and again, I'm quickly going over this, is that there were relatively few clear examples of shoreline erosion damage to infrastructure or safety. Operation, noise, courtesy, and conflict were the ones that were identified as greatest concern. And I will fully admit it. We go out, we water ski, we jet ski, but by dinner time, we come back in, I cook dinner, have a drink, no more going back out onto the lake. And it's at that moment that I sit down on the dock and you're watching the sunset. And it's at that moment that I find the jet skis to be the most difficult to deal with. And that's what we are identifying. So I'm not trying to put my own spin on this. What I'm doing is I'm using it as a way to say, I get what they're saying when it comes to this courtesy and conflict. It does make sense. And that came through on many people's surveys. But we do have examples of biophysical and structural impact of wakes in short fetched environments. And those are sediment resuspension and shoreline erosion. It's because in those small fetch environments, boat wakes not only represent more energy, they represent more bigger energy, much larger than any wind wave could ever create on that lake. But one of the other issues that we identified is that there's a lack of consistent definition or examples of impact in larger fetch environments. So what does impact actually mean? And in some areas, has the damage already been done? In order to then manage wake impacts, either by biophysical, structural safety, it requires a definition of that impact and the associated tolerances. How much more sediment should be resuspended versus that of a wind wave? We don't have an answer for that. So this represents three different management strategies. The first one is to study results. That again, no shoreline is in this study was unaffected by boat wakes, but it's not clear whether that increased amount of wave energy or the fact that we had much larger waves on that lake really represented an impact. Is it causing demonstrable erosion, sediment resuspension, and to what degree is that a problem? Now, strategy number one would be to limit the percent of total wave energy created by the wakes. So essentially, it's to reduce the carrying capacity of a lake and to say only X number of boats by time, etc., should be allowed to be on this lake. So you limit the amount of boating activity to lower the frequency of the wave capable of having an impact. And again, you define that carrying capacity. You might then reduce the total amount of wave energy. You're still going to have more than wind waves because you're just adding another form. And you haven't dealt with the case of these much larger waves that can come through. So you might say that I have a carrying capacity of 100 boats, but they could all be wake boats. So you can't just do strategy one and assume it will fix all the issues if you know what those issues are. And strategy number two, apologize, got to move my side piece here. Strategy number two is to limit the maximum wake that can actually be generated on the lake. So this is by defining buffers, areas where you're allowed to sail or not sail, areas where you have no wake and wake zones. Or is to simply say that wake boats are only allowed in the center part of a large lake. Here, you're changing the wave height, the energy that actually reaches the shoreline, but you're not changing the total energy within the system because you're still allowing for more waves to actually be generated. Essentially, it's going to be if you wanted to manage this and you had a good understanding as to what is the impact and what is the threshold that I have to meet to say to reduce these, uh, to get under that impact, it would be some combination of strategy number one and strategy number two. So eventually, you'd have to define these buffer zones based upon where you want to sail. And if we use this particular example, if the wind was coming from the left to the right and everybody sailed along A, you're actually going to reduce you're going to reduce the total energy of waves, and they're not going to be any bigger than the wind. But if everybody sailed on line C, they're going to be much bigger than the wind waves still. You're adding still a lot more energy. So you've got to think about how that lake is used. What is the wind directions associated? What are some of the vulnerable shorelines or infrastructure that you're trying to protect? And you can start building that out. That would then define buffers and carrying capacity. So I use a very simple example here. I said, well, what's the distance to the sailing line for a wake height to be less than the maximum wind wave height for all the lakes that we looked at last year? So this is not necessarily something that is directly associated with the lakes that you might be on. This is the lakes that we looked at in our study. And what we found is that in using data from Lake Conway, is that in order for the boat wakes to be less than the wind waves in terms of height, so total that energy at the shoreline, you would need to have that boat 383 meters offshore, or a lake that is greater than 760 meters wide. And you can see that 200, even a cruising vessel in shallow water still requires 200 meters from the shoreline in order to have waves less than that of the wind waves. So when we looked at it, the vast majority of the lakes that we studied across Ontario in terms of where we got the survey data from, and consistent with what we saw in the perceptions, is that the vast majority of lakes that could not meet these requirements were the ones that had big impacts identified by their residents. So this suggests that a lake smaller than 765 meters in diameter, assuming it's a circle, you're going to have wake impacts that are far greater than the wind wave could ever generate. So this assumes that the impact can be minimized by limiting wakes to the maximum wind wave height and energy for a given fetch. And again, it's all based on data from 2020 to 2023. It is for a certain specific set of lakes, but it does provide an approach that can be used. So if we are currently collecting other current and historical evidence of shoreline erosion, damage to infrastructure, etc., if you've got some that you're interested in, please send them directly to me by my email. As well as for summer 2026, we are planning to do a study again in Northern Ontario, looking at water quality issues, that sediment resuspension. And so with that, I will hand it back to you and we can do questions.
Yeah, great. Thank you. That's fascinating, and I'm so glad to hear that you're looking at that water quality question because that's a huge one here. I've seen maybe one or two efforts by consultants in the States to try and measure turbidity in lakes after periods of high boating activity versus periods of, say, just wind or a calm lake. But I haven't seen like proper research on that issue. So I'm excited to see what you come up with. Um, I'm going to jump back up to the top of the questions here. One question was around how would you define a shallow lake? I think the one example you gave of that really small lake in the beginning, you described as shallow. What would that depth be?
And so that particular lake was about 2 to 3 meters in depth at its greatest. There is not a good definition of a shallow lake, but the best way of putting it, a shallow lake is where the wake that is generated immediately off the boat would immediately be touching the bottom.
Gotcha.
And
Okay.
and and so if you have a wake that is 5 meters, so from crest one to crest two is 5 meters, that touches bottom at 2.5 meters. So it's going to be based upon that, but there is not a good definition for that. So it's one of those that was the shallowest lake that we looked at.
Just for clarification, the distance between the crests of the wave divided by two is the vertical height underneath the water.
That's exactly it.
Okay, got it. Thank you. There's a question here from Jerry. Transport Canada has a general 10 to 30 boating rule, 10 kilometers an hour within 30 meters of the shore to limit wave impacts to the shoreline. Based on your research, is this rule sufficient to limit wave energy at shorelines in Alberta?
No, and in fact, that is assuming that in fact that boat is just perfectly displacing, just slowly going on the water surface. One, I can also go 10 kilometers an hour in full plow mode and make the biggest waves possible. Or I could have a wake boat right there. The other piece is that based upon that, what our analysis shows is that even a boat that is cruising close to at say 10 kilometers an hour is still going to produce a wake bigger than that of a wind wave for a lake less than 700 meters wide.
Interesting.
But the
Okay.
other is the other is if I forgot to mention that also if this is assuming the wind comes from one direction. You know, if I'm on the side where the wind is where those wind waves are hitting, yeah, it's gonna be small relative to the wind wave. If I'm on the other side of the lake where it's calm, I'm in the lee of the forest, I'm gonna create a big wave that the wind wave is not generating.
Interesting. On that note, I was wondering, and possibly I missed it, if the fetch of the lake, it seems to me like along the fetch of the lake is the direction where the waves will be greatest at the windward side of that fetch. And if boats are traveling along the fetch, the wave energy kind of goes the opposite direction, right? Like perpendicular to. So do you see like interference effects of boat waves and wind energy?
No,
Okay.
no,
I don't know if that question made any sense, but
no, it,
uh,
it, it made sense. Yeah.
there's another question here from Carolyn. Is there any amount of waves reducing based on peaks and troughs, or is this diminished by predominant patterns of travel? That might be a similar question to what I was just trying to ask Carolyn. Um,
I'm not 100% sure I understand the question.
yeah, if you
Yeah.
want to clarify your question in the chat, or if you're able to unmute yourself, Carolyn, feel free to, and we can try and dig into that question.
Yeah, so I'm just thinking it might be more in the smaller lakes or the bays where you might have boats going in circles. Would you get a lot of churn and causing suspension, or would the waves cancel each out, like the peaks and troughs at some point cancel?
No, in
Or
fact,
it's not sufficient.
yeah, when waves interact with each other, sometimes you get interference and they destruct each other, and then other times they construct, but they're passing through each other. And so you just create a secondary, larger wave system. So I know myself going around and around and around in a boat or in a jet ski, I can make some really large waves for the tubers that are behind me. And I purposely do it to make the biggest wave possible.
Got it. Thanks, Carolyn, for clarifying that question.
Thanks.
Kelsey is wondering if you had any measure of the wind speeds. She's saying in southern Alberta, we can get gusts up to 70 kilometers an hour. In central regions, more close to around 50 kilometers an hour. Do you have data on that?
No, so that is one of the reasons why I highly focused on this being a regional study for Northern Ontario. in Alberta, you're going to get far stronger winds over and with some smaller lakes as well. And so it is a very different wind environment, and you would want to be able to then look at what could be created by those winds. And then to your point about the seasonality, if our seasons in Ontario, we go quiet diurnal winds through the summer, is that the same in Alberta? So how does the wind vary relative to activity? That's exactly the point. That's why we focused on the summer, because that's when you're changing when your waves and your wakes are totally out of sync with each other.
Great. Another question here from Jerry. I believe quite a lot of research has been done on emergent vegetation to mitigate wave energy, mostly eelgrass, but other aquatic species as well. Based on your knowledge, how effective are they in wave mitigation, and how much do you need to mitigate wave energy?
Yeah, and it goes also to submergent vegetation as well.
Yeah.
In fact, I've done quite a bit of work on wave attenuation through vegetation, and we've looked really at how the differences in wave periods influence the vegetation and interact with it. But one of the things that's key is that if you've got emergent vegetation like a thick bulrush, thick Phragmites or something like that, they're extremely effective because the vegetation is extremely rigid and dense. If you get something more submergence, and you got like coontail, you've got little seagrasses, or grasses, they are extremely flexible. And as a result, they just go with the flow. They don't do very much, and you would need a significant distance offshore by which that wave would eventually be attenuated. So the kind of the more rigid, more dense emergence, very effective in a very short period, short distance. However, is that the shoreline that people want, or is that et cetera? So you have to kind of play through what it would work, but it is very effective.
Interesting. Yeah, there's efforts at least one of the lakes here called Wabamun Lake to do bulrush restorations and relocations of bulrush in areas where they might have been removed. So that's interesting that the emergents are more effective at mitigating wave energy.
Yeah.
Kelsey's asking if you included in your survey questions about how the respondents used the lake themselves.
Yes, and in fact, we did ask them directly, and it was sent through cottage associations, which include cottage and owner associations. So people who own property on that, whether they are seasonal cottagers or year-round residents. And we did ask them about their own boating activity as well. And just like myself, they all did it. So the vast majority did it. So in fact, we did make sure to ask that question.
Great. Two comments here just thanking you for your presentation and saying it was extremely informative. And I echo that as well. Dawn is wondering, do you think people would accept these results, which would result in them limiting their boating activities?
So it is a very bimodal response. And I think the best one is you watch some of the Cottage Association Facebook pages. And every summer somebody will say, "Hey, this boat," without naming them, they would, "Hey, this boat went down the Narrows and it created very dangerous conditions for us," or "These boats are constantly eroding our shoreline." And the you'd get some people who would agree with them and say, "Yeah, we need to have changes in speed limits, buffers, capacity, etc." And then you would have the complete vitriol of um, this is my freedom. I'm allowed to do so. It's quite surprising what we have seen as we've done this and done the analysis, that in fact it resonates with some, but they were already on the no wake, like the safe, quiet lake type groups. For others, it's having no impact and it's don't tell me what to do.
Question here from Rod. He says that Sylvan Lake is a deeper, longer fetch lake. For context, I think Sylvan Lake gets up to about 18 meters at its deepest. And they say that they place buoys along the shore out to 100 meters to create a no wake zone, but maybe based on your research, should they be placing the buoys at a minimum depth of 2.5 meters to reduce churn and sediment resistance?
Well, I think that goes back to the uniqueness of the lakes within this region. So it would come down to what is the shape, what is the typical sailing lines that are on that lake relative to that shoreline? What are the depth configurations? Just to better understand what is that right balance between ensuring that the wakes, when they do reach that shoreline, are smaller than that of the wind waves, but also not completely constraining the activity that might be further offshore. So I don't have a good answer for you, but it would be some combination of distance, which affects the dispersion of the wave, and depth is when the waves finally start touching the bottom and have the potential to actually churn up sediment.
Great. Carolyn's wondering about education campaigns as a component of this research.
So in fact, we're not on the educational side. We provide the analysis like this to about what are we seeing? What is the relative energy of wakes? We're not in the advocacy role either way. And so we leave it to presentations like groups like yourselves, Safe Quiet Lakes, etc., to then bring the education piece forward.
So I got a question from me, like how do we clone you to do this research out in Alberta?
So, well, I think this is something that we are continuing to do. I moved from another university just in the last year and a half, and so I'm rebuilding my graduate group right now. Um, and so as a result, I'm at low capacity this year for other further studies, but it's 2026 that we have the potential to do more. But also, these pressure transducers that we make are very, very easy to use and very easy. And so, in fact, there's an opportunity for more of a citizen science approach where, in fact, people can put them out there. We'll provide guidance. We'll do the analysis for you. But in fact, it doesn't mean that we have to physically be out there. And as long as um, interprovincial trade barriers are reduced, it doesn't matter if I ship some pressure transducers to you.
Amazing. Yeah, we have a very engaged network of citizen scientists here in Alberta. And as you know, relative to Ontario, very few major recreational lakes. So I think wouldn't be that challenging for us to collect data on some of our major recreational water bodies. And they do span that range of size, absolutely, in terms of like shoreline morphology, convoluted shorelines versus more simple circular lakes, and then span the whole length of depths and surface area. So I think we'd be able to generate some really great data out here. Do you have time for a couple more questions? I don't want to keep you.
No, by all means.
There's a question here about Muskoka. So you might be able to help me navigate this one as well. But it says, with the increase of population in Muskoka and increase of short-term renters, the carrying capacity of lakes has been a recent topic of discussion. Do you see a resolution of this research increasing in wakes? Do you see a resolution of this increasing in wakes being created? Have you worked with the Muskoka Watershed Council or the District of Muskoka, since they have a good water quality program? This individual is on the council and knows they'd be interested in learning more about this.
So I'll go to the second piece first, and that is I work on a snowball effect, which means as people hear about the research that we've done and invite me in, I'm more than happy to speak to it. So if there was an opportunity to talk to the Muskoka Watershed Council or the District of Muskoka, happy to be invited there. Again, obviously with the cottage up that direction, I'm up there on a regular basis. Two, with respect to the increase in population, yeah, this is an interesting piece to it, particularly after the pandemic, and a lot of people from the Toronto region moved up to the Muskokas as kind of their work from location and also retired. There's not only been an increase in the population, more constant activity, but more people, particularly those who are retiring up there, using it as a destination to get away. Boat wakes also represent that nuisance that is disturbing that sunset scene. So the tension associated with boat wakes is increasing not only because there's an increase in population, there's also that conflict over usage and activity that is starting to grow, particularly when you then start adding in the short-term renters that will come onto the lake. They don't know the lake. And they're using it in a way that is permitted, but not necessarily respected or respectful to those who are owners or longtime cottagers. We're starting to see that. This is why I think this research started to come together and why we've been talking to a lot of people is because we're coming to the head of the tension.
Interesting. Kirsten is wondering, can you share any insights on how boat wakes impact fish or fish populations? Because at least in Alberta, our recreational lakes are really popular for fishing.
Yes. And so, in fact, in addition to things like just direct impact or noise impacts, which there is quite a few studies on, with respect to the boat wakes, they are causing damage to whatever that near shore ecosystem might be. So if it's a vegetated spot that becomes devegetated, eroding, then you might be losing spawning habitat. But also for things such as bass, which will create a spawning nest in a sandy beach and create that perfect circle. You get some big waves that are going to come through. You're going to potentially wash out that nest. And so, in fact, there is a lot of work to be done in looking at the impact of boat wakes on fish population. There has been some work done in the United States, but I think there's still a lot of opportunity for more work there.
Great. Nancy says you've got great data and a great presentation. Thanks for sharing. And Dawn is just making a point here that ice pushes from thermal expansion of ice have a very significant impact on shoreline changes here in Alberta.
By all means. And we have the exact same thing. At our cottage, water levels through the winter rise by 3 feet, and the ice push is extremely significant. It's one of the reasons why at our exact spot, because we're on a really long fetch, we get that ice push straight up the rocks, and they're barren for much higher than they would be just by the waves alone. This is why, again, it's very specific to each type of lake. You can't just generalize that it's causing erosion. Because if you're on this particular lake and you've got a strong ice push, boat wakes might be the least of your problem. So I completely agree with Don there. But again, that's why this data is good for Muskoka. It doesn't necessarily translate, but I think it gives you an opportunity to start thinking about those questions.
Yeah, that's really interesting. How would you recommend people actually document changes to their shoreline? Because I don't think it's probably photographs of the shore are often in the photos. It's probably out onto
Yes,
the lake,
it is.
right?
It is photographs of the shore. So that one program that we run called Coasty with Parks Canada is simply a little post like this. And this coming summer, you're going to see them also in BC parks as well as some of the Alberta parks for monitoring glaciers. All you do, and so I'm showing you an example here. All you do is you put your phone into this stand, and everybody takes the exact same photograph. And if you can do that, you can start to document changes that are occurring through time. So if you're able to, you don't need a metal post like that, but as long as you are taking the exact same picture from the exact same spot, then you can start to document that change through time. And that it's just going to be a long record. And so we have these stands going around. We have about 8,000 photographs in 2 years of beaches and shorelines from around Canada that we are starting to document that material. And then if you're in a very unconsolidated environment, so it's not rocky or something else like that, as Don says here, you can also then use land survey data and start to be able to look at it, use Google Earth to look at shoreline changes. That will give you that historical pattern, and then you can use some of these photographs to actually begin looking at it in shorter periods of time or associated with specific events, whether it be the ice push, the 70-kilometer-an-hour winds, or increased boating activity through a certain part of the year.
Yeah, that's a great idea because I think most people are pointing their cameras away from the shoreline when they're going out to their lake and taking nice photos as opposed to turning around and taking a shot of the erosion, right?
I might be the unusual one there.
Yeah, exactly. If there's any other questions, feel free to throw them in the chat. And Dr. Hauser, if there is a good way for folks to connect with you, feel free to add that into the chat as well, whether that's a website or, yeah, your email there is perfect as well. I'm going to throw up on the screen here the information about next week's webinar, which again is on a study on Lake Windermere around their recreational carrying capacity. And I know Lake Windermere is in BC, but my understanding is almost 80% of the boats on Lake Windermere are coming from Alberta. So it is relevant to the folks here in Alberta. So I hope you guys will tune into that. Just give me 1 sec, I'll throw that QR code back up on the screen here. There we go. Let me just make it a bit bigger for you. Perfect. Dr. Hauser, I know you have back-to-back meetings until 9 p.m. tonight. So I want to thank you for carving out some of your time today to talk to the folks in Alberta here. It's a hot issue here, and you've given us so much great information. I'm really excited about what you've done already, and especially excited about the work in 2026. That's going to be fascinating, and we'll have to have you back.
Perfect. Thank you very much.
Yeah, very nice to meet you. Thanks. Take care and good luck with the rest of your meetings today.
Yep.
For everyone else on the call, I really appreciate your attendance, your great questions, your great audience. Thank you to Kelsey and Kirsten Latender and Kirsten Perrin, who in the background were helping to navigate this meeting. As I said, our last meeting of the Lake Stewardship Community of Practice is this upcoming Monday at noon. So again, feel free to tune in for that. And we're very pleased as well to have received additional funding from the Land Stewardship Centre of Canada to continue our webinar series and engagement on topics like these into the next year, into 2025, 2026. So stay tuned for more information on that. On Monday's webinar, we'll be doing a bit of a survey and some feedback about future topics that you'd like to hear about. So if you're able to join us Monday, great, we'll get your feedback then. If not, feel free to throw in the chat or send us an email. I'll put my email in the chat about topics that you're interested in learning about through more of these meetings. With that, I'll keep the line open for a couple minutes. Otherwise, enjoy the rest of your day. Thanks everyone for joining us. And I'll go ahead and stop the recording as well.